Hey Global Impact students, this is Mr. Ellinger. This is our first lesson in Unit 2, and Unit 2 is titled Solving Equations and Inequalities. Some big ideas in Unit 2. First one is regarding equivalence. Any algebraic equation can be represented using symbols in an infinite number of ways where each representation has the same solution. Some essential questions regarding equivalence. Can equations or inequalities that appear to be different be equivalent? Another one, how do you represent relationships between quantities that are not equal? Another big idea in this unit is solving. Properties of numbers in equality can transform an equation into an equivalent, simpler equations. This process is used to find solutions. An essential question regarding solving, how can you solve equations or inequalities? Our third big idea is regarding proportionality. Proportionality involves a relationship in which the ratio of two quantities remains constant as the corresponding values of the quantities change. In a proportional relationship, there are an infinite number of ratios equal to this constant ratio. An essential question regarding proportionality is what kinds of relationships can proportions represent? So our first lesson here is regarding solving one-step equations. We have one learning target for the lesson. We want to be able to solve one-step equations in one variable. Essential understanding for the lesson is equivalent equations are equations that have the same value. Also, the solution of a one-step equation can be found using the properties of equations and inverse operations to write a simpler equation. Background for the lesson: inverse operations and properties of equality help solve equations. As you isolate variables, you must use inverse operations. For example, the equation x plus 3 equals 15 shows addition of 3 to the variable x. To solve, you will undo the addition. You will use inverse operations to solve for the variable in one-step equations. Remember, when discussing division properties, we can't divide by 0, and 0 does not have a reciprocal. To solve an equation, you must isolate the variable. You do this by getting the variable with a coefficient of 1 alone on one side of the equation. You can isolate a variable using the properties of equality and inverse operations. An inverse operation undoes another operation. For example, subtraction is the inverse of addition. When you solve an equation, each inverse operation you perform should produce a simpler, equivalent equation. And a lot of times, we use a balance, a scale balance, to represent equations or to keep in mind what's going on in an equation. Think of a balance, a scale balance. And if we have the equation 2x plus 8 equals 18, and that's what equation is represented here in this scale balance. On the left side we have 2x plus 8, and on the right side we have 18. When these two expressions are equal, the scale is in balance. And as we start doing things to this equation to solve it, to isolate the variable, we have to keep the scale in balance. So you can see here in red these little minus 8s. They're implying that we need to subtract 8 from both sides. And we keep the balance in the equation, or the scale, as long as we do the same thing on one side as we do on the other side. Okay, so just keep that in mind. Whatever we do to one side, we have to do to the other side to keep the balance. We have addition and subtraction properties of equality that we will use anytime we're solving an equation. These are probably the most common ones that we'll use. You see the addition property of equality states that adding the same number to each side of an equation produces an equivalent equation. So over here in general, we have for any real number a, b, and c, if a equals b, then a plus c equals b plus c. So if we add c to both sides, the expression or the equation does not change. Same thing with subtraction. For all real numbers a, b, and c, if a equals b, then a minus c equals b minus c. So let's work out some examples. In our first equation, y plus 2 equals negative 6. We want to isolate y, and on the left side of the equation, we have y plus 2. So the opposite, or the inverse of adding 2, is to subtract 2. So what we need to do is we need to subtract 2 from both sides. Your book will write the subtraction of 2 this way. Here's y plus 2 what we start with, and then we will subtract 2 from both sides. And they just work all in one line across the page every single time. I do things a little differently, and you can use whichever way you like. I like to solve my equations in a vertical fashion, and the first thing that I do is I draw a line through my equal sign, basically dividing my page into 2 halves. And that helps me remember that whatever I do on this side of the line to the equation, I also have to do on this side of the line to the equation. So again, if you like this method, you can, or you can work horizontally as the book does. So I know that I'm trying to isolate y. So I will subtract 2 from both sides because I'm basically doing the opposite or the inverse operation of adding 2. Okay, so I'm going to write minus 2 on both sides. Okay, and I'll put a line here, so I'm basically working in a vertical fashion here. Y, I'm not doing anything with y, so I will bring the y down. The plus 2 and the minus 2, that gives me a 0. So we say they cancel each other out. But it's really, we're creating 0 there. We have our equal sign on our line. And over here on the right side, we have a minus 6, negative 6, minus 2. Negative 6 minus 2, just calculate it as is. Negative 6 minus 2, that's negative 8. So the solution to this equation is y equals negative 8. And one thing that we can always do is go back to our original problem, substitute our solution in for our variable y here, put negative 8 in. Negative 8 plus 2 equals negative 6. Is that a true statement? Well, negative 8 plus 2 is negative 6. Negative 6 equals negative 6. So we know that's our solution. All right, let's go over here to the right. Negative 14 equals m minus 8. So here I'll split my equation in 2 parts, 2 halves, 2 equal sides. Here's my variable that I'm trying to isolate, m, and I'm subtracting 8 from m. So the opposite or the inverse of that is to add 8. So I will add 8 to both sides of my equation. Minus 8 and plus 8 gives me 0. So on the right side I've got m. On the left side, negative 14 plus 8, that is negative 6. So my equation is solved. M equals negative 6, or negative 6 equals m. Either way, we have the same expression. The third equation down here, we have 1/2 equals y minus 3/2. So here's our variable that we're trying to isolate. We're subtracting 3/2 from y. So the inverse of that is we will add 3/2 to both sides. Here we have a 0. So the right side of my equation has a y. The left side of my equation, 1/2 plus 3/2 is 4/2. Well, 4/2, we can simplify that. 4 over 2 is 2. So we have 2 on the left, y on the right. There's our solution. We can also use multiplication and division properties of equality to solve equations. And they go hand in hand with addition and subtraction. Here's our multiplication property of equality. Basically says you can multiply an equation by anything you want as long as you do it to both sides. Same thing with division down here for any real number a, b, and c, so that c does not equal 0. If a equals b, then a divided by c equals b divided by c. And we have to put this little condition on here, c cannot equal 0, because we know we can't divide by 0. Basically this says we can divide both sides of an equation by anything we want as long as that thing is not 0. So here we have a few examples. Our first example, negative 4x equals negative 12. Here's our variable. We're trying to isolate the variable. In the equation, it says negative 4x. Well, we know that's negative 4 times x. The opposite of times or multiply is division. So we are going to divide both sides of our equation by negative 4. Negative 4 divided by negative 4 is a 1. Remember, our goal was to get x by itself, but not just x, a 1x, and that 1 is implied. We don't have to write it. We can if we want to, but it's not necessary, and it's a good habit to get out of if we do. Negative 12 divided by negative 4 is 3. So the solution to that equation is x equals 3. Second example here, we have b divided by 4 equals 2.1. So let's split our equation in half, 2 parts. B divided by 4. The opposite of divide by 4 is to multiply by 4. So over here, what we're going to do is we're going to multiply this fraction by 4. And if we do multiply by 4 on one side, we have to multiply by 4 on the other side. Now, 4 times b over 4, this is like 4 times 1/4 b. 4 times 1/4, those are reciprocals of each other. And we know that when we multiply reciprocals, we get a 1. So multiplying this by 4 will give us b, or 1b. Over here, 2.1 times 4 is 8.4. So our solution is b equals 8.4. This example is a little strange. We have a fraction in front of our variable equaling 6, but a fraction or a number in front of a variable is implied multiplication. So we have 2/3 times p equals 6. So we want to get rid of the 2/3, meaning we want to multiply this by something that gives us 1p here. So again, if we have a fraction, remember, the way that you get a coefficient of 1 on p is to multiply this fraction by its reciprocal. The reciprocal of 3/2 is 2/3. So I multiply both sides by 3/2. 3/2 times 2/3 is 6/6, which is 1. So we get p on the left. 6 times 3/2, the way we multiply 6 times 3/2, a whole number by a fraction, is to remember to put the whole number over 1, multiply the numerators, multiply the denominators. 18/2 reduces down to 9. So our solution in this last equation is p equals 9. And again, any one of these solutions, we could test them by putting them back into the original equation for x or p or whatever our variable is, and we should get a true statement when we work out both sides. So that's how we solve one-step equations. Have a good day.